let's look at an example in which we are going to apply this particular method so that we get the equation of a line that is going to best describe the relationship between two variables. Now let us assume that we consider, or let's assume that we have 80 fathers. So consider the ages of 8, we could say 8 children. In this case, 8 children, and their fathers, and the age of their fathers. So the ages of their fathers. So in this particular case, the age of the child, and then we are going to have age of father, the age of the father. We would like to find out whether there is a relationship, a linear relationship between the age of the father and the age of the child. So we will take the age of the father as y and the age of the child as x. So for each and every value, this is what we're going to have. So assuming that we have here the child is 21, and then the age of the father, the corresponding father, is 44. Then for the others we have 24, we have 25. While for the 24 is 49, the age of the father is 49, and for the child who is 25, the age of the father is 49. So we also have 26, 27, 28, 30, and 32. For the child who is 26, the father is 52. And then for the child who is 27, the father is 53. 28, the father is 59. And then here is 57. Or the age of the father for a child who is 32 is 58. Now we would like to find the relationship between these two variables, the age of the father and the age of the child. So in the first place, from what we have, from the formula that we have been given, you will see that we need to find the value of A and the value of B. We have already said that A is going to be equal to y bar minus B x bar. So what it means in this particular case, we need from these particular values, we need to get the sum of x, we need to get the sum of y, and we also need to get the sum of xy, then the sum of x squared. Because these are the values that we are going to substitute in the equations of interest. And at the same time, what will be the number of data pairs that we have in the data set. So to find these particular values, let's follow these particular steps. Very simple steps. So using the same data that we have, what we can do is just to create some other columns which will actually give us these particular values. So like in this particular case, we just have to add this to get the sum. So we can add so x, the sum of x is actually, you are adding all these particular values. The sum of y, you're also adding these particular values. The only thing that we need to find as another column is the product of x and y. So it means you are saying the values of x multiplied by their corresponding values of y. And then another column which is going to give us x squared, which is going to give us x squared. So for those that have got calculators, can actually help us to get these values. So they can help us to get these particular values. So like for example, if you check the column for xy, you see that this gives us a 924, while the x squared is going to give us 441. For this other row, if you square the values of x, should actually give us the values of x should actually give us 576. While this column, which is the product of x and y, can actually give us a 1176. The other one will give us a 1225. Then here we have 1352. Then 1431. We also have 652. Then the other one, we're also going to have 1710. Then finally, we have 1856. 856. While when you are squaring the values of x, you are going to have, as I said, 441, 576, then 625. You have 676, and the other values will have 729. 28 squared gives us 784, and then 30 squared 900, and finally 32 squared, that's 1024. So when we get these particular values, so we are saying for this column, why we have come up with these is because the formula demands that we should get the values of the sum of x and y, and then the x squared. So to say that this particular part is not sum as it is, the sum will come up to the end, but we need first of all just to get the product of x and y, to get the product of x and y. So this times that, it is giving us that. This 24 multiplied by 49 is going to give us that. 24 squared giving us that. So at the end of the day, then after you have calculated all these particular values, you now need to find the sum. That is the addition. You add all the values. Add the values in each and every column. So if you add the x values, in which case we can put the symbol, the sum of x is going to be equal to, from the values of x, you see that it is going to give us 213. While the other column, where you are talking about the values of y, this one is going to give us the sum of y equal to 421. So 421, that's the value, while the other one will give us 11,000. This one is the sum of x, y, should give us 11,326. So 11,326, and the last one, which is the sum of x squared, should give us 5,755. 5,755. Now, after you have got these particular values, you can now substitute in the equations of interest for us to find the values of A and the values of B. So we have a summary of, we have calculated the values that we need to insert in our formula. Remember, so I can rub off this part so that we can now insert the values. So I hope everybody has got the values that we have in this particular case. So remember that our B is given by the sum of x, y minus the sum of x multiplied by the sum of y divided by n the whole thing here divided by the sum of x squared minus the sum of x bracket squared over n. Now in this case, remember, our x is the age of the child and y is the age of the father. Now because we are saying the sum of x and y, the sum of the product of x and y, from what we have calculated, remember that the sum of x and y is 11,326. So we substitute that particular value here. Then we subtract this. We are going to subtract the sum of x, which is 213, multiplied by the sum of y, which is 421. Then divide the whole thing here by the number of data pairs. So remember, we were saying 8 children. So because we are saying 8 children, we are going to divide this by 8 because our n is 8. That's the number of data pairs. This one divided by the sum of x squared. The sum of x squared. And our x squared, we said, is 5,755. Then minus the sum of x squared. Here many people make a lot of mistakes. They think that this is the same as that. No, they are different. Here we have put the bracket, meaning to say that you first of all add the values of x and then square. While here, you square the values of x and then sum them up. So that's why we had 213. Then this particular value squared divided by n. Our n still remains 8. Our n still remains 8. So you subtract 213 squared divided by 8 from 5,755. So when you work out this, for those that have got calculators, you will see that the numerators, this particular numerator, that's the top part, is going to bow down to 116.8 116.875, so 116.875 divided by the denominator is going to give us 83.875 as well. Then when you divide this denominator into the numerator, it should be in a position to give us 1.39. With some other values, it could be 3, 4, 4, depending on the calculator that we are using. It could give us more values, 4, 4, 2, 6, and the like. We can put this answer to 2 decimal places, so b is going to be equal to 1.39. So we have found we have done the first step. This one is to 2 decimal places. So 2 decimal places. So we have done the first step. That is, we find the value of b in the equation of interest. Once we find the value of b, then we can use this particular value of b to get the value of a, where the value of a is now the y-intercept. The y-intercept. So we now need to get the value of a, having got the value of b. Having calculated the value of b, let's look at the value of a. A, as we like to say it, is actually the mean of the dependent variable, the values of the dependent variable, minus b multiplied by the mean of the independent variable. So remember our y bar, it means that the ages of the father, you add them all and then divide by the number of individuals that you had. So we had y bar is actually going to be equal to, we had 421 because that was the sum. So to say this, what we're saying here is y bar can actually be found by the sum of y divided by n. And this one is 421 divided by 8. That can actually give us the value. So if you try to calculate that, it should give us 52.625 years, because that's the age of the father, the age of the father. Now, in terms of x bar, it means x bar is the sum of x divided by n. And we know the sum of x was 213. So 213 divided by 8, which gives us, if we punch it on the calculator, should give us 26.625, something like that. 26.625 years. So the mean age of the children is 26.625, while the mean age of the father is 52.625. Then it means that we are going to take these particular values and substitute in the equation of interest so that we find the value of A. We have already calculated the value of B, and therefore it will be easy for us to calculate the value of A. Let's substitute and see what we are going to have. Let's substitute in the equation of interest. So our y bar is 52. So it means in this case that A is going to be equal to 52.625 minus our B. From the calculations that we have made, we found that our B was 1.393446. Of course, there are several other numbers, but for the sake of calculations, make sure that you put as many decimal places as possible when you are calculating, and then you round off at the end. Remember, we rounded off to 2 decimal places, but when you are calculating, make sure that you use a larger number of decimal places so that you are not far from the true value with a bigger margin. So this one multiplied by x bar, which in this case is 26.625 years. So we multiply that and then subtract that particular value from 52. You will see that when you do calculations, it will be 52.625 minus, if you do your multiplication, this should give us 37.000, probably 000, here there's 1, and then there's 4 here. So when you subtract, this should be giving you 15.5, something like that. 52 and some other values like 49, which we can approximately say is 15.52 years. That is to 2 decimal places. So 2 decimal places. So to 2 decimal places, you are going to have 15.52. So it means that we have now found these 2 values, the value of A and the value of B. Now we need to find, to substitute in the equation of interest. So our equation then, because ideally we wanted to minus BX, sorry, plus, yeah, that's one. So this was our equation, the linear regression equation, the general one. And we made the interpretations of this. So we have found the value of A and we have found the value of B. Now we can substitute in the equation. It means that the y hat is going to be equal to the y-intercept, which is A, 15.52 plus. Now, when you check the value of B, we got, the value of B that we got was, we rounded off to 2 decimal places. It was 1.39x. Meaning to say that when you are, remember the y is the age of the father and the x is the age of the child. It means that we can comfortably say age of father is equal to 15.52 plus 1.39 age of the child, age of the child. So that's the relationship. It means in this particular case, we have come up with the linear regression equation describing the relationship between the age of the father and the age of the child. Next time we are meeting, we are going to look at how we interpret this particular equation, and then come up with a graph to represent the same information so that we can come up with the least linear regression equation or line, so to say, that will best describe the relationship graphically. So when we meet, we're going to do that, and also try to calculate what we call the residuals. That is the residue. We're looking at the random errors, or we call them the sum of squares which I mentioned. How do we calculate them? We will have to substitute the values of x in the given equation that we have calculated and be in a position to come up with what was the error that was committed when we are trying to calculate this.